All right, chapter 7. Not necessarily, doesn't start off the most difficult because I know that you've done a lot of this work before in, middle school or maybe even towards the end of your elementary time. But I think what happens to a lot of you is the words really don't mean as much to you as they should. For example, when you see the word ratio, a lot of you probably colon comes into your mind because you can see the number, colon, another number. But really what I would prefer happens is when you see ratio, you almost think of a fraction. I'd prefer that to happen. Is it okay to write a ratio with the colon? Yeah, that's fine. But I would prefer you start thinking of it as a fraction because a ratio is simply a comparison of two numbers. And it's going to help you if you compare those two numbers as a fraction instead of setting them up the way you have in the past. And you notice here in example 1, I kind of do have them set up as a fraction instead of the other way of writing it. And so why don't you take a second here and determine the ratio in this classroom of basically boys to girls. Or you could even, the word two in between. I will not be counted in this, and do not count people that are not here today. Hopefully we all get the same answer, but we'll find out. Is anybody supremely confident in their answer for boys to girls? Morgan? No, you're not? Okay. Chris? 11 over 4? So that would mean this is predominantly males in here. Is that correct? Does anybody disagree with the 11 over 4?
Yes.
Dakota? Nope, because it's just boys to girls, not boys over total. Right? So then girls is 4 over 11. Yes, for those of you that listened, I do not count. Now, what Dakota was doing was almost basically probability, which is much later this year, of saying 11 over 15 would be much more of a probability idea. But that's just your ratio, again, in a fraction. Is it okay, technically, if you wanted to say write it that way? It's the same thing. Or you could even say like that. But I want you to get in the habit of maybe using the fractions. I know you don't probably like fractions, but it's going to be helpful in this particular chapter. So right here we have what's called a proportion. Another word that I know you've heard before, but unfortunately doesn't probably mean enough to you as it should. And what it basically is two ratios set equal to each other. So in other words, I'm going to kind of look at it as two fractions set equal to each other, because that's what I look at as a ratio, is a fraction. I'm sure many of you have been taught many different ways of solving these. I'm going to teach you a way that's going to probably be the safest for you in this class. So I do it that way so that you do all the problems the same way and said, oh, this one's easy, I'll just do it this other method, and then this problem's harder. Well, now I don't know what to do. Okay. So many of you are looking at A. When two fractions are equal like that, you can cross multiply. And most of you would look at that and cross multiply and divide is probably what you're thinking to do. But let me show you really what's happening here, and then it'll help you on the more complicated ones like letter B. When two fractions are equal, you can just take the diagonals like that and multiply them. So you take 3 times 12, which is 36, and you can set it equal to the other diagonal when you multiply it. And 4 times x is 4x. So one diagonal equals the other is one way of looking at it. And to solve what we have left, let's face it, we'd rather solve this one in green than the fractions we had earlier, right? That's probably how you'd rather look at it. And so then divide by 4. Does 36 divide by 4 evenly? Yeah, how many times? 9. Okay. What that means is if I put 9 back in the place of x in the original, it should be true. Well, let's take a look and see if we agree with that. If I put 9 right there, are those two the same? 3 over 4 and 9 over 12? Are they actually equal? Is 9 the only answer then? Is that the only one that's going to make this work out? With 12 on the bottom? Yeah, that's the only answer that's going to work out here. Now, some of you are saying, well, I just looked at the bottom. This bottom got multiplied by 3, so multiply the top by 3. That's fine on the easy ones. Not quite as easy on letter B to do it that way. Okay? Some of you might still try that, but it is more difficult. And that's why I like this method. do the kind of, you can call it the cross multiply method here. So let's face it, 7 times 4, that's not that hard. What is that? 28. Now here's the harder one though. So that diagonal is going to equal the other one. I have to take 8 times 3t minus 1. Yep, Elena just came back and ruined our ratio. We're done now. So you take 8, now watch what I do, times 3t minus 1. Because I have to take that entire numerator times 8, which in other words means I have to do what with the 8? I have to, well, you could divide by it or distribute. Okay. Does dividing by 8 look like a good option for this problem with 28 over there? Probably not the best, right? It's not going to work out as well as we would hope. So I would say distribute the 8 then. So we still got 28 over here, no big deal. So we distribute the 8. 8 times 3t is 24t. Is it minus 1 then? It's minus 8. Very good, because you got to take 8 times that as well. But do you see how easy it would be is if you just look up here and just have 24t minus 1 and just get going way too fast and make a mistake? That'd be very easy to do. So probably the best way to solve this then is to get the numbers together. So let's add 8 on over here. So this side ends up being 36, yep, equals. Did we do anything to the 24t? No. So let's leave that right there. And the 8's cancel. Well, how do you solve something like that? You divide by 24. Does 24 go into 36 perfectly? Unfortunately not. But what we can do is take a look at that. Is there a number that does go into 36 and 24 evenly? It goes into both of them. Is there one that does that? A 12 does? So if you take a 12 out of there, you get 3. You take a 12 out of there, you get, so t is 3/2. Do you think it would be okay to write 1.5 then for this answer if you wanted to? Yeah, how about 1.5? Would that be all right? Yeah. Any of those ways is fine because that's the final answer. Do you see what I mean? I don't think many of us are going to look back at that original, oh, 3/2, just put it in, it's going to work out perfect. All right? Where a lot of you probably saw the answer to letter A probably pretty quick. Okay? So you see what I mean, that this method will work no matter what. Why don't you try letter C right now on your own then? All right, let's see what you did on this one then. So is this one of them? You can just take a peek at that. Oh, it's this. Well, it's probably not the easiest thing to do. So here's what you're going to do. You're going to take 11 times that, which is 11x. And then 7 times that. Again, it means 7 times the entire thing. You can't just pick and choose what you're going to multiply by 7. It has to be that entire numerator. And so what do you actually get on the right side of the equation once you distribute? 14x minus 21. So this is different from the last one because we have x's on both sides. Does that necessarily make it any more difficult at this point? Not really. Did the original have way more variables? Yeah, but it really didn't make a difference. So I would probably subtract the 14x because that makes these cancel, but you have to be careful what you write once you do that. 11x minus 14x is negative 3x. Very good. Equals negative 21. And so now you can divide by negative 3. I would take the negative right with it because then the negative 3 cancels, leaving you with just x. And x would be 7. Okay. Any questions on that one? And actually, example 3 will probably be the last one that we do today. I don't think we'll have time for example 4. Example 3, it's another way of using proportions, and you may never have thought of it before. I will tell you, though, that the ACT and the college placements are starting to like questions like this. So maybe let's take our time on this one. It says the perimeter of a triangle is 64 centimeters. Again, perimeter means around the outside, right? So when we add up all the sides, I better get 60. Does that mean they have to be really nice numbers? No, they just have to add to 60 when we have all 3 of them. But it does say the ratio of the measures of the sides is 2 to 6 to 7. So determine the measure of each side. So we know in the end, once everything's simplified, it has to be 2 to 6 to 7. Now, you could guess and check, but here's what I would do. I'd say this is probably the 2, right? And this is probably the 6 over here, and that's probably the 7. Doesn't really matter where you put it, but I'm kind of figuring which side's going to be bigger. And what we're going to do is we're going to say, if I multiply them all by the same number, do they still have a 2 by 6 by 7 ratio? If I multiply them all by the exactly same number, yeah, it's going to have the same ratio. And then what it does is it allows a variable into the problem, which allows us to solve. Because now I can figure out the perimeter algebraically. We already know the perimeter numerically. So what is the perimeter algebraically? Well, you take 2x, and you add 6x, and you add 7x. How many x's are we looking at? So there's 15 x's. That's the perimeter as far as algebra is concerned. The perimeter as far as numbers is concerned is 60. So we can solve for x quite simply by dividing by 15. So x ends up being, now it's for the answer to the question. Again, if this was an algebra class, 4 probably would be the answer to the question. You'd be done. But being in geometry, it has determined the measure of each side. So all you have to do then is put 4 back in. So this side right here is 8 centimeters, correct? This side over here is close, 28 centimeters. And the last one is 24 centimeters. And what would be a pretty quick way of checking to see if you did that right? Yeah, does that get you to 60? It does. So there are the measures of your side. And do they still have a 2 by 6 by 7 ratio? Yes. Now imagine had you not been taught that, you see this on an ACT, you start guessing numbers, what do? You know, it's like, what's going on? But now that you've seen one of these, realize they can do the same thing for angles. They can say this triangle has a ratio of angles of 2 to 6 to 7. And they really don't have to tell you anymore because you know the angles have to add to 180. And you do it a similar way. All right? So any questions on that? Yeah, example 4 we're going to skip for today because I don't think we have time. We may come back to that a little bit later in the chapter. So any questions on the notes?